Assalamu alaikum students. I hope you all will be fine. Today we'll perform practical 12.5. Its statement is find the focal length of convex lens by parallax method. The material required for this practical is convex lens, optical bench, knitting needles, two uprights. Student convex lens is a lens convex lens is the lens which is thick at the middle and thin at the edges, and this lens is used as a simple microscope also. In case of convex lens, the rays that are parallel to the principal axis after passing through the lens converge or meet a single point called principal focus, and the distance between the principal focus and lens is called focal length. In this practical, we will measure or calculate the focal length of a lens. Students, to adjust the operators, you can see in the figure, this is our objective needle and this is our lens stand and this is our image needle, and above the image needle we can see the inverted image of objective needle, and through here we can see the inverted image. By moving our eye left to right, we can make the objective needle tip and the image needle tip coinciding with each other. If this is, then parallax is removed. If the tip of the image needle and the tip of the image of objective needle move separately, then there is a parallax. So we have to remove the parallax by moving the image needle toward the lens or away from the lens. Before starting the practical, we have to measure the approximate focal length of a given convex lens. So this is screen which we use to get the sharp image of a bright object. This is our convex lens, and this window will act as a bright object. So we use the convex lens to focus the window on the screen. By moving the lens toward the screen or away from the screen, we'll try to get the sharp image as you can see in the figure, and then after getting the sharp image, we will measure the distance between the screen and the lens, and we will calculate or measure this distance. This distance is the approximate focal length of a convex lens. To perform this experiment, we have to adjust the operators as shown in figure. In this figure you can see the optical bench in which scale, needle stand and lens stands are included. The lens stand will be placed approximately at the middle of the scale. As you can see, it is placed at the distance 50. At right side of the object lens, we'll place the image needle, and left side of the lens will place the object needle. The distance between the object needle and the lens will be adjusted according to our focal length, the approximate focal length. Let's suppose the approximate focal length of our convex lens is 10. So we'll place the object about 20 centimeter from the lens. 20 centimeter is the double of 10, which is approximate focal length. As we know that when object is placed at 2f, will get its image at 2f. So this technique is used to perform this experiment by adjusting the or by placing the object needle at the double of the focal length. We'll see from the right side, as you can see in the figure, the inverted image of the objective needle, and we'll try to align the inverted image tip and the tip of the image needle such that when we move our head left or right, or moving our eye left or right, both tips, the tip of the image needle and tip of the inverted object needle, will move together. If they do not move together, then there is a parallax. We have to remove the parallax by moving the image needle toward the lens or away from the lens. Such condition will come when both tips will move together. After the alignment of the tips or removing the parallax, we will then measure the distance between the object needle and the lens. This distance will act as our object distance P, and we'll also measure the distance between the image needle and object and lens. This distance will act as our image distance and taken as q. So we know the formula, lens formula, 1 over f equals to 1 over p plus 1 over q. Using this formula, putting the value of p and q, we can calculate the focal length of a given lens. This is only for today. Allah Hafiz.